Today in 5.2, we are going to talk about how to show triangles are congruent using what we call SSS and SAS. Knowing that we're talking about triangles, what do you think the S's and A's stand for? Sides and angles. So side, 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 and side, angle, side are what these stand for. Anyone need more time with their objective? Okay. So, spoiler alert, side, side, side. Congruence postulate in words. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Yesterday we had to know all the sides and all the angles. So starting today we're kind of learning some shortcuts. So this is saying if all you know are the sides, that's enough to say the triangles are congruent. So let's call these triangles A, B, C, and D, E, F. So if we need to make three congruent statements about the sides. Now, since they have not marked anything in these triangles, they're pretty generic. We can kind of decide for ourselves what parts we want to match up to each other. For example, if I wanted to start off with side AB, I need side AB to be congruent to some side in the other triangle. What side do you want it to be congruent to? DE, sure. So if that's true, I'm going to give them both one tick mark. Then we need another pair of sides. So I'll move on to side BC, congruent to EF, sure, that's fine. They didn't tell us, so we're kind of getting to pick here. That would leave side AC congruent to DF. Now, if all of this is true, that's enough for me to then say that the triangles are congruent. Again, when we write a congruent statement, we choose how we name the first one, so I'll call it ABC. Then the second one has to be named accordingly, so the second one would be DEF. So we can know nothing at all about the angles. As long as we know all pairs of corresponding sides are congruent, that's enough for us to know that the triangles themselves are congruent. Questions, concerns? Anybody need more time on this slide? Okay, we'll keep it moving. Does the diagram give enough information to use the side, side, side congruence postulate? Explain. So for 1A, do we have enough information to use side, side, side? So we're hearing some yeses, some no's, maybe some confusion here. So how many sides, pairs of sides, did they mark for us? 2 pairs of sides. But to use side, 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 I need how many pairs? 3. However, there's something special about that third side. That third side is used in both of the triangles. So if I were to cut these 2 triangles apart, they would both include side AC. Does that make sense? Okay, they're both going to have that side AC if I were to cut them apart. AC. We all see that? Okay, so what do we know about side AC and side AC? They're the same, so they have to be congruent. Does anybody remember what property states that? Good. Reflexive property states that any side or angle or number is equal or congruent to itself. So knowing that, do we have enough to use side, side, side? Yes, okay, because the reflexive property gave us that last pair of congruent sides. So, yes. All pairs of corresponding sides are congruent. And if you want to make a note that we use the reflexive property, if you want to make a note that we use the reflexive property to get that last pair, you can. That's how we got AC congruent to AC. All right, next up. Do we have enough information to use side, side, side? Bella, what do you think?
Oh, I have a question.
Oh, a question, sure.
So, we'll have a quiz over this section, right?
Eventually, yes.
Will we have to name what property it is?
Yes. Yes, we're going to be learning several of these congruence postulates and theorems. You will have to be able to tell me which one's being used.
Isn't there a transitive property or something?
Yes, I don't know that we'll use transitive anytime soon. But yes, transitive is a property that we learned a while back.
No, it's not crazy. I mean, it's not congruent.
Okay, so we don't think we have enough information to show that these are congruent on letter B. Why not?
We only have 2 sides.
Okay, they only gave us 2 pairs of sides. Are any of the sides shared like they were in letter A? No. So here, no, there's not enough info. They gave us 2 pairs of corresponding congruent sides, but they did not give us that third pair. We don't know anything about FG, and we don't know anything about JK. Questions about example 1? Need more time on that slide. Okay. On we go. Example 2, same question. What do we think about the first one on example 2? Why not? Good, so they marked 1 pair. Which other pair do we know? BC by the reflexive property, so we could mark that one with 2 tick marks. But we still don't know anything about AC. We still don't know anything about CD. So there's still not enough information because of those 2 sides we don't know at all. What about on the second one on this slide? Yes, that one's pretty easy and straightforward because they marked all of them for us. 1 tick mark, 2 tick marks, 3 tick marks. So yes, all pairs of corresponding sides are congruent. Questions, concerns about side, side, side? All right. We'll keep moving. Let's talk about side angle side. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. We are asked the question of what is the included angle? The included angle is going to be formed by the sides used. So it is the angle formed by the sides used. So we could draw a picture for the included angle. If I mark this triangle as A, B, C, and I'm using sides AB and AC, which angle is included in between those two sides that I marked? A. Okay, so if we were to trace over those sides that I marked, I would be tracing over angle A. So angle A is the included angle in this situation. Questions about what it means to be the included angle? Okay, so then if we wanted to make a picture for side angle side, I don't know that I'm going to write out all the congruent statements, but I'm gonna have a hard time fitting these in here. I'm gonna drop it below. Okay, so let's call this LMN and QRS. So if I were to know that LM is congruent to QR and that MN is congruent to RS, that takes care of my pairs of sides. 2 S's, 2 pairs of sides. So then I would also need the included angles congruent. So which 2 angles would I be working with? M and R. So M and R congruent. This picture gives us an idea of what side angle side is going to look like. So if I just have this much information, then I could say that those triangles, LMN is congruent to triangle QRS. Okay, questions, concerns about side angle side before we try to identify it some? Need more time on this slide. Okay, on we go. Does the diagram give enough information to use side angle side? Well, they gave us some sides, right? What sides did they give us? So I want them in pairs. So VW is congruent to ZY, WX is congruent to XY. Okay, so then what is the included angle up above? Not what angle they marked. What angle's included? W. If we were to trace over those sides that they used in that triangle, W is the included angle. Did they tell us anything about that angle? No. What about the included angle down below in the other triangle? Y. Angle Y. Did they tell us anything about angle Y? No. So can we use side angle side? No. They didn't give us the included angles congruent to each other. It doesn't really matter that we have those right angles down there. Okay, here's a helpful hint. Angle side side is not ever going to be a reason for triangles to be congruent, because we don't write bad words in geometry. So we don't use angle side side. Okay? If you don't get it, write out what the abbreviation for angle side side would be and then erase it. We don't write bad words and we don't write bad words backwards. So side angle is also not a thing. If they have the angle in between the two sides, our angle better be between the two sides. So no, we don't know the included angles. So there's not enough information there. We would have wanted angles W and Y to be congruent to use side angle side. Questions on example 3? Need more time on this slide. Okay, keep it going. Does the diagram give enough information to use the side angle side congruence postulate? What do we think about number 3 on this slide? Yes. Okay, they gave us 2 pairs of congruent sides, and if we trace over the sides that they marked, the angle they used is included in those. So, yes. If it's a yes, I don't necessarily need you to write out a whole long explanation for it. But if you're going to tell me no, you better be telling me why not. Okay, so I'm fine with just a yes on that one. On number 4, can we use side angle side? No, why not? Sort of. What about the included angle? Good. P is not an included angle. So the first triangle they set up for us is good. Right? That's the included angle there. Ooh. Okay, so M is the included angle, so that's fine. But if we look at the second triangle, P is the one that they marked, but that is not included between those 2 sides. So we'd be looking at those angle at R. So this one does not work. So no, and just saying P, angle P is not included is a good enough explanation for me. Questions, concerns about this one? Ready to keep going? Okay, on we go. We need to talk a little bit about writing proofs, what we've all been looking forward to. A proof is a convincing argument that shows why a statement is true. A 2-columned proof has numbered statements and reasons that show the logical order of the argument. So we set out all of our information in order. Each statement has a reason listed to its right. So there will be 2 columns. On the left, we'll write our statements. On the right, we'll write our reasons. Anybody need more time on those blanks? Okay. We've got a few steps on how to write a proof. Top of that next page for you in your notes. First, we list the given information. Everyone is going to be able to do this because every proof starts off with some information that you are told right away. Then we look at our diagram, see if there's any information from the diagram that we can use. Things like vertical angles or linear pairs, things that we can see in a picture. We will give a reason for every statement that we make. Use given information, definitions, postulates, and theorems as reasons. A lot of the times, after the given information, we use definitions and postulates. If you don't know the difference between whether it's a postulate or a theorem, I'm pretty forgiving about that. But think about any definition we've learned or any time we've written a postulate or a theorem, things like segment addition, angle addition, the definition of perpendicular, parallel, corresponding angles being congruent on parallel lines. All these things we've learned all year long are going to be fair game to use in proofs. List your statements in order. Sometimes that order can vary a little bit. And the proof with the statement that you are trying to prove. Whoops, sorry. Back. So we'll know we're done when we finish with whatever statement they gave us as our prove statement. Questions, concerns, need more time on these? Okay, let's give it a try. This one's not so bad because half of it's filled in for us. So, see, when they set it up, they give you some given information. So we are told that WZ is congruent to YZ. That is also already marked for us in our diagram. Sometimes things will be marked for you, sometimes they will not. We are also told that XZ bisects angle WZY. And we can see they listed that down here at number 2 for us already. So, statement number 1, they said the reason was that it was given to us. So what given statement did they not list out yet? Down here below. Good. They listed the second part of that given. They didn't list the first part. So they didn't list that WZ is congruent to YZ. Now I know some of you might think it's silly to say that when they just wrote it out above. That's how proofs work. You start off listing your given information, which is honestly kind of nice because then at least you know you're getting some sort of points on your proof if you start it correctly. On step 2, where did they come up with this information? Where did we see XZ bisects angle WZY? In the givens. That was also up here. So our reason for number 2 is also going to be given. Now personally, when I write proofs, I list all my givens in the same step. So I would have put a comma and listed out the bisector next to it. It doesn't matter to me if you want to put them all on one line or if you want to split them up. Either way works. Next, they use their reason as a definition of an angle bisector. So that means we have to know what an angle bisector does and make a statement based on that. What does it mean to bisect? Split it into 2 equal or congruent parts. So if we are bisecting angle WZY, then what 2 angles have to be the same? Nope. What is it, Sam? Nope. How do we name angles? How many letters are we allowed to use? 1 or 1 or 3. If we only use 2 letters, what are we naming? A side. So if we are bisecting an angle, then what sort of objects are congruent to each other? Angles or sides? Oh my goodness. We are bisecting an angle. That's going to give you 2 congruent angles. Are we all okay with that? XYZ and ZYX would be the same thing. Do we see the angle I traced over? That's the angle that's getting split into 2 little angles. So what are those 2 little angles? So after all that, we would have to list out that angle WZX is congruent to angle YZX. We cannot call both of those angle Z because there are 3 different angles at Z. The little ones and then the big one. Questions before we move on from our angle bisector? Okay? What allows us to say that side XZ is congruent to itself? This is something we talked about earlier. The reflexive property. The reflexive property allows us to say that a side is congruent to itself, so we can give it 2 little tick marks. The last statement they make matches the prove statement. That's where they got it from. The prove statement should always come last. So we are proving that triangle WXZ, so the small triangle on the left, is congruent to triangle YXZ, the little triangle on the right, and we have to give a reason for it. Now, so far, we only know 3 different reasons why you could say 2 triangles are congruent. One of them we talked about yesterday, where we knew all the sides and all the angles. Do we know that today? Do you know all your sides and all your angles? No, so that's out. We can't use that. What are the 2 new ways we learned today? If you're not sure, I'd look for the big boxes in your notes. What are the 2 ways we learned to prove triangles congruent today? Side, 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 and side angle side. Those are the 2 new ways we talked about today. Which one applies here? Side angle side, so you can just write SAS. Okay, we had 2 pairs of sides and the angle in between those sides congruent to each other from each triangle. Okay, now that we've got this diagram labeled, let's start looking through what information they gave us. So they told us that CB is congruent to CE. We can go ahead and mark that. And what would our reason for that be in our proof? Given. Givens should always be the easiest. Step 2, their reason is also given. So what other given information have we not stated yet? Good. AC congruent to DC. So we can mark those. Next, they're telling us that angle BCA is congruent to angle ECD. So normally that's something you would have to come up with on your own. Since this proof gave us some help, we didn't have to do that. But we do need to know why they're saying those 2 angles are congruent. Nope, we weren't told we have a bisector anywhere. What's the relationship between those angles? That kind of is part of it. They're formed by 2 lines that intersect at point C. But this makes them what? They're not the same exact angle, so they're not reflexive. It's not the reflexive property. Anytime you have 2 lines that cross each other. I thought somebody might have said it. Oh, no, maybe not. So, for example, these 2 lines cross, so those 2 angles are congruent to each other. It's a V word. Vertical. Vertical angles are always going to be congruent. So if you just put vertical angles there, that's fine. We have to remember all our angle relationships that we've talked about. So from the diagram, we see that those angles are vertical. We can go ahead and state that they're going to be congruent because they are vertical angles. Finally, they listed the proof statement. Triangle BCA is congruent to triangle ECD. Why is that? Side angle, side again. Questions, concerns about example 6? Okay, we got one more. Let me try to label this one for us real quick. Okay. L is the midpoint. J, M. There we go. That's mine, so I'm not worried about it. All right. Statements and reasons. This one's totally blank. What's my first statement? Good. First, we've got JL congruent to NL. What's my reason for that? That's given. Okay, now again, I would usually put all my givens together, but we'll go ahead and split them up just for space. So my second statement would be what? Good. L is midpoint. I'm going to shorten that up of side KM. My reason for that? Also given. Okay, I can go ahead and mark that JL is congruent to NL since we've stated that. So after we've stated our givens, you can kind of choose. Do you want to look at your diagram or do you want to look at your givens to get more information? It doesn't really matter to me. You want to go with the diagram? Okay, so from this diagram, much like the last problem, what's something that we could say? Because they are vertical angles, what do we know about them? They're congruent. So I could say that angle JLK is congruent to angle NLM. My reason would be vertical angles. Okay, so anytime you have a diagram, things like vertical angles or things like the reflexive property are going to be common things you can see out of a diagram. All right, takes care of that. Let's go back then to our given information. We marked that JL and NL were congruent, so we can move on. L is the midpoint of KM. What does that tell us? Good. If we have a midpoint, we know that a midpoint acts kind of like a bisector would. And KL would be congruent to LM. So now that I've stated that, I'll mark it. What's my reason for that? Definition of a midpoint. If they give you a word that we've defined before, most likely you're going to use its definition at some point. And I'm okay with shortening up some of these words a little bit. Okay, now don't put D period O period M for definition of a midpoint. I'm not going to know what that means. All right, we got one line left. What do you think our statement's going to be? Good. We should always end with our prove statement. What do you think our reasoning is here? What is it? Side angle side. They didn't give us our last pair of sides here, but we did use the included angle. Side angle side. Questions about our proofs, our notes? Side, 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 angle, side. Yes, ma'am. When we do our reasons? Yeah, sometimes you'll use theorems in there instead of just definitions or diagrams.